All right, in this set of notes, we are again going to be looking at triangles. Now, specifically in this case, we're going to be asking, what does it mean? What does it mean for two triangles to be congruent? Question mark. All right, let's take a look here. All right, well, before we do that, let's take a look at segment congruence and angle congruence. So, segment congruence. So, if we were to say that segment AB is congruent to segment CD, we would write that as AB, and there's the symbol for is congruent to CD. And it would mean that segment AB is the same length as segment CD, which we would write as AB equals CD. I would say that basically if one of these statements is true, so is the other. It's not correct to say that they mean the same thing, but if I told you that these two statements that this statement was true, you could conclude that this statement was true, that the segments were the same length. If you knew the segments were the same length, then you'd know that they were congruent. So, in a sense, yes, they kind of mean the same thing, but not exactly. Next, let's take a look at angle congruence. Angle congruence. If I said that angle A is congruent to angle B, I would write that as angle A is congruent to angle B. And remember, there are several ways to write angle names. This is just one. And this would mean that the measure of angle A equals or is the same as the measure of angle B, which we would write as measure of angle A equals or is the same as measure of angle B. Again, these don't exactly mean the same thing, but if one statement is true, so is the other. So if I told you that these two angles A and B were congruent, you could conclude that their measures, their sizes, were the same. And if I told you that these two angles had the same size or the same measure, then you could conclude that they were congruent. So in a sense, yes, they kind of mean the same thing. So next up is the question of what does it mean for two triangles to be congruent? So if I told you that two triangles were congruent, what sorts of things could you conclude automatically from what I told you? Let's take a look. Let's say that triangle ABC is congruent to triangle DEF. I would write that as, here's the symbol for triangle, triangle ABC is congruent to triangle DEF. So, if I were to say draw these out, I'll draw some pictures of them, what they might possibly look like. That. This one over here, maybe like that, and then like that, and then kind of like that. I'll draw this line up here. Yeah, so here's my two triangles. They look pretty much the same. I'll put a mark there. I'll put a mark there. I'll mark that angle. I'll mark that angle. And I'll mark this side and this angle. And I'll mark this side and this angle. And then we'll go shoop, shoop, shoop. All right. Oh, and I should call them, let's see, A, B, C, D, E, F. Okay. So, what this means is, as I've marked it, side AB is congruent to side DE. So I'm going to write over here, sides angles. So I would say that side AB is congruent to side DE. And then I would say that side AC is congruent to side DF. And then I would say that side BC is congruent to side EF. So the triangles have 3 pairs of congruent sides. Of course, this also means that AB, the distance between AB, is the same as the distance between D and E. The distance between A and C is the same as the distance between D and F. And the distance between B and C is the same as the distance between E and F. So the sides are congruent, which of course you could conclude from that they were also all the same length, because that's what it means to be congruent. But it also tells us something about the angles. It would tell us that angle A is congruent to angle D. It would also tell us that angle B is congruent to angle E. And it would tell us that angle C is congruent to angle F. Which, of course, from that we could conclude that the measure of angle A equaled the measure of angle D. That the measure of angle B equaled the measure of angle E. And that the measure of angle C equaled the measure of angle F. So, just to go back and recap, if I told you that triangle ABC, we name triangles according to their 3 vertices, triangle ABC was congruent to triangle DEF over here, what I'd be telling you is that each side in triangle ABC was congruent to a side in triangle DEF, which would mean that each side in triangle ABC was the same length as a side in triangle DEF. I would also be telling you that each angle in triangle ABC was congruent to an angle in triangle DEF, which would mean that each angle in triangle ABC was congruent to an angle in triangle DEF. Basically, all the parts of triangle ABC match up with a part in triangle DEF, and the other way around. Every part in triangle DEF matches up with a part in triangle ABC. And actually, the way we write this out is that corresponding remember, we've talked about this word corresponding before. It means matching up, matching, matching. parts, corresponding parts, and by that we mean angles and sides of congruent triangles are congruent. Oop, off the page there a bit. Congruent. And by that we mean, actually it's not in quotation marks, same size or measure. Okay. Corresponding, matching, so parts that match up, corresponding parts, and by parts we mean angles and sides of congruent triangles are congruent, meaning same size or measure. That's what it means for two triangles to be congruent. All the angles and sides match up with an angle or a side from the other triangle. It's the same measure, same size, same length, etc. All right, and we're done.